Bobby, you represent Fortanix in Canada, employee number 1, I believe. Patrick, you've come by way of California. Am I getting it right? Chief Revenue Officer for Fortanix. They've put together a really good use case for us. They'll show us what they've been doing in collaboration with NVIDIA, demonstrating how compliance can be designed into the foundation of AI systems, ensuring both data sovereignty and security in use. So their case study is forthcoming, and I look forward to that. Over to you, Bobby.
All right. I'm going to have Patrick go up and do the magic discussion.
Oh, very good.
I don't need to stare at him up there.
I see.
Well, yep, thank you. Thank you, Donna. Thank you, everybody in the CRTA. I think this is my second or third event coming to get a chance to speak with you all. Let's see, forward button. There we go. Okay, we're going to talk about achieving data security and sovereignty in this new AI world that we're all a part of. We're talking about some of the partnerships that we've put together with some of the other technology leaders and some of the use cases that we're moving quickly towards with some of our customers. So I'm the Chief Revenue Officer for the company. I've been here for about 6 years. I've run global business development channels, other partner and ISV parts of the company. And yes, I am an American. And when I went to the bar at the hotel last night, they said, American, eh? And I said, yeah. And I thought maybe it was, you know, because I was using sports jargon for everything, like, I'm going to hit a home run in the presentation tomorrow or something like that. But I think it was actually when I said, as I left the bar, Happy Thanksgiving. So. All right. So very quickly, this is a bit of a busy slide. Don't worry about the little boxes and the bigger boxes. I want to just tell you a little bit about Fortanix just for context. So we are a data security innovator. We're based in Santa Clara, California, and we are leaders in one particular part of data security that's called confidential computing. The confidential computing is using memory encryption to protect data in use. So you guys all know data is either at rest, in motion, or in use. It's the 3 states, just like solid, liquid, gas for matter. The in-use part is the tricky part, right? So you use memory encryption to protect that data once it gets to a destination server, or once you want to spin it up and run something with it, an AI model or some kind of machine learning, or as we've done with the things on the left-hand side of this diagram, data security. So we use that in the place of custom crypto chips to do things like encryption, key management, post-quantum. So these kinds of advanced cryptography functions are done out of that encrypted memory in a product we call Data Security Manager. As we move to the right, we see Confidential Computing Manager. That is a control plane that we built to allow you to run orchestrated applications where you want to have something inside of the encrypted memory, not the data security stuff, but let's just say an AI model or possibly now as we move towards generative AI for either training or inferencing some specific kind of an application. So confidential computing manager is very important because it does things like it'll build an image, it'll lift and shift that image into encrypted memory, and then it will do something called attestation. So attestation is the second thing you have to have confidential computing. The first one is you have to have isolation of the memory from everything below it so that you can have a trusted environment even if the infrastructure is untrusted. The second thing you have to have is attestation. And that just means that every part of a transaction is able to be proven, is able to be shown that it was run inside of encrypted memory, that nothing leaked, that the person that was running it was the right one, the workload was the right one, you know about the infrastructure. So it's a complex thing that is absolutely critical for any kind of confidential computing. Then all the way on the far right-hand side is something that we'll focus on a little bit more, and that is RMET. So RMET AI is our platform for running generative AI. It is an end-to-end secure platform. Everything is inside of the encrypted memory. Everything's inside of confidential computing, including all of the communications between the different stages of the AI pipeline. Now, why this is important is because as customers have looked at how can we utilize the power of generative AI, right? And people want to use the learning systems. It's very, very flexible. There are lots of different models that can be used that are pre-trained and other things. A few challenges have emerged, right? So number one, complexity, right? What's the time that's required to build your own solution? How many pieces do you have to curate? What's the cost of that? Well, I mean, there are numbers for this, right? The cost is, anywhere up to $1 million or more. The time is between 8 and 18 months. As far as the complexity in terms of the number of pieces you have to pull together, depends on what you want to get done. But complexity is one of the things that's been a challenge. The second one is really where we have played our entire time as a company, the security side. But security, it's not just data security, it's privacy, it's compliance, and outside of the United States, it's sovereignty. And these are things that we deal with all the time. We deal with them with our data security business, and now we're dealing with them as it relates to generative AI. The third thing is trust in the result, right? And that has to do with how do I make sure that the right person is able to ask questions about the right data in a generative AI model and not someone else. And that the wrong person is not able to ask questions that might poison a model or might create bias or might cause the model to hallucinate. So this trust in the result is as important as the other two pieces. But these are the things that have been really creating a scenario where AI investments have lagged. Right? People are spending money, but they're dabbling, right? And to be honest with you, this is really why the partnership with NVIDIA was put together. NVIDIA being the number one player in the technology around generative AI. The reason why I show you this slide is this is just an example of the journey that some of our customers are trying to take themselves on as it relates to building a generative AI solution. We don't need to read this. We just need to understand this is the complexity that we're talking about. And I think the box that popped on just before the last one is really about the guardians of the process, right? The security organization. What happens when they weigh in? They want to see everything, and they need to see everything. So how can you prove to them that you had a secure process and that you should trust in the result? So these are the things that we tried to solve for with our RMET AI platform. What's happened is, as we've been out in the marketplace for the last 2 years talking to, we have around 200 global companies, and most of them are very large banks and other financial services companies, government agencies, energy, these types of large regulatory, regulated industries. A number of use cases have emerged for generative AI. There's a lot of them, right? But research, fraud detection in the financial space, other things that fit underneath fraud detection, things like detecting money laundering behavior or possibly human trafficking types of behavior, financial analysis, CFOs and other people within organizations wanting to be able to create reports that can go to regulators. Research, genetic research, other kinds of research in the medical field. And then another one that's not up here but is sort of woven through here is collaboration, right? Data collaboration. We see it a lot in pharmaceuticals. We see it a lot in government. That is where you have a number of people that want to combine their data together, but they want to make sure that each of the other can never see the data. So you use confidential computing to be able to put those things into encrypted memory and run an agreed upon model against it to get some type of an encrypted result, right? So these are the things that as we've talked to customers, and this has also been borne out by partnerships with companies like NVIDIA, who is a deep partner with us in terms of generative AI. So if these use cases are emerging, and we have customers that are doing these things, some of the fraud detection stuff, the things that I mentioned before, the genomic research, we've got customers that are doing these things. How do we secure? How do we secure in the generative AI space? Well, our answer to that is an end-to-end platform that we call RMET. So what we tried to do is solve for the three key areas that we've been talking about. One being on the security side, so that's the security, the compliance, and I'll explain how we're doing that. I'll explain, because I know this is a reg tech environment, so we'll talk about how we do that, how we inject compliance and governance into the the AI pipeline. The second thing is really something that would take the complexity away, right? Something that can be turnkey, that can get someone to be using the power and performance of this capability very, very quickly. And then the last thing really is for the different marketplaces that we've talked about already. And again, sovereign AI is becoming a real thing outside of the U.S. There's an AI factory being built with NVIDIA, with HPE at TELUS. So there are AI factories. AI factories are one of the answers to how do we build this quickly and then make this available to customers. You have to be able to segment an AI factory into jobs and into different companies in some cases. So that's where the cybersecurity piece comes in. NVIDIA has been developing GPUs that have confidential computing capabilities in them for the past several years, but they've never built a control plane that can actually orchestrate it. So that's what we've done with our MET AI solution. The reason why I bring this slide up is that Justin Boitano, the VP and GM of Enterprise AI for NVIDIA, showed this slide at the recent GTC DC event in Washington, DC. And we thought it was pretty cool to be placed between, so some bigger companies than us. Hope to catch up with them someday, but the Gemini angle here is for Gemini on premises, right? So, and what NVIDIA asked us to do was help them build something that could be run air-gapped on premises or in a private cloud. So what I'm showing you here is a typical kind of a RAG AI environment, a pipeline with different stages to it. What we do with our MET is we secure it. Number one, every part of this process is inside of encrypted memory. It's not the same encrypted memory. You have to have CPUs with encrypted memory. You have to have GPUs with encrypted memory. You have to have multiple GPUs. But that's number one, is that everything is inside of encrypted memory. The second thing is very, very important, and this is where the compliance and governance comes in, are guardrails. So guardrails, and a lot of AI companies are building things that they're calling guardrails. NVIDIA has them, HP has them, Dell has them. We built guardrails that are an AI process. They're inside of encrypted memory, and they're actually an AI process that is where you inject your policy for what in PII, PHI, PCI, or custom policies or governance you want to allow through to the model. And things that you don't want through, it gets redacted or it gets tokenized right at that point. And so we put those guardrails in between the processes. Also, all the communication is encrypted. It's all encrypted so that there's no leaking from the data all the way through to the model. And then the third thing that's a part of this solution is where we tie in the role-based access controls for a specific kind of data to the person or people that are allowed to access that data. So a CFO can access some things possibly in SharePoint or maybe other parts of the data estate, but they're not able to access maybe things that may be the purview of sales or engineering or research and development. And that's the same for any function. Is you tie the role-based access controls, you integrate the role-based access controls that exist for the data to the AI process. And that is how we really make sure that the compliance piece is front and center. So these three pieces together allow you to have a model that you can secure end-to-end, that is simple because actually all of these pieces are curated and you can point and click, I want this embedding model, I want this vector database, I want this LLM, including some of NVIDIA's models, their NIMs, and some of their tools, their NeMo tools are being integrated into our MET so that you can buy them all at once if that's what you want to do. So this is really how we provide geofencing, because all of these things are going to be within some type of an AI factory. Also, how we deal with the compliance and governance part of the equation. So we're kind of in the home stretch here. This one is a little bit complex. And what I'll tell you is, if you're interested, we can have a conversation about how attestation works, how we built something called composite attestation that looks at everything that goes through every CPU and every GPU, every job that moves through there. And there's a kind of a complex exchange of certificates and keys that allow you to open up that encrypted memory and decrypt inside the encrypted memory. So that's basically what this is showing you. And all of the parts of our product line, our data security manager for doing all the encryption key management, and our confidential computing manager for doing all the lift and shift in the attestation, and then are met as a platform. Those are the things that allow you to pull this together into one place. What we introduced together with NVIDIA at 2 weeks ago at their GTC was a reference design or a validated design for being able to run generative AI in AI factories on premises, fully secure end-to-end. And so the takeaways are, number one, NVIDIA enabled confidentially computing-enabled GPUs provide the power, performance, and the capability of security to run these models and to run them in production. Secondly, that Armet AI allows you to simplify the process and gives you an end-to-end solution that also includes these capabilities. And third, that enterprise and sovereign AI factories are going to use these piece parts to be able to deliver something where you can run production models much, much faster and sooner than you might have had to do if you were going to pull all the pieces together for yourself. This is one of our screens, and on the far left hand, far right, your right hand says "Know Your Transaction." That is where, when you did a job or you had a project, you click on that, all of the code comes up to show you the attestation to show you that everything was protected from the secure data all the way through to the trust result. And that is my story.